Good evening, everyone. Today we will be talking about R square. The R square is nothing but a performance matrix which is used in the regression. So, I have written a formula for R square here, that is 1 minus SSR upon SST, where SSR stands for sum of the square residuals and the SST stands for total sum of squares. Total sum of squares. Just see here. What do you mean by SSR? SSR is sum of the square residual, and residuals means what? Error. Error means what? Actual value minus predicted value, and it is square, so we have squared it, and it is a summation, so this is the sign. Now let me tell you the formula for SST also. The formula for the SST will come out. We will find the mean of the actual y values which are given to us, that will be y bar minus each value of y, true value. Then we will just square it and then we will do the summation. So this is the R square formula, and I have also tell you the formula which is used here. Now we have this R square, but we don't only stop here, we also have an adjusted R square. Now for what purpose? Where the R square is failed. Suppose if we add some new independent features in our data set, the R square value is increased whether whether our input feature which we have added is useful or not. So for this purpose we have another concept, that is the adjusted R square. Now let's see for the adjusted R square. For the adjusted R square, we have the formula 1 minus R square multiplied by n minus 1 n minus p minus 1, where n represents our total number of points in the data set, p represents the number of independent features, R square is our R square only, and this is my whole formula. So what happens is that this fraction which you can see here, it is called the penalty, and whenever we increase the value of the p, what will happen? The denominator in this fraction will increase. Okay, so if the denominator in this fraction is increased and the numerator is still the same, so what will happen? That is, no, it is not the same. uh, the numerator is now greater, and by increasing the value of the p, we have decreased our denominator value, so it is small. So what will happen? On increasing the number of features, our penalty value increases. Now see here, we have two cases. Suppose if the useful features like I have added, for example, if I have a house price data set and I added a feature called location, so we all know that location has an impact on the prices of the house. So what will happen? In this case, the R square value will increase. When we add a significant important feature, then a increase in the R square value is seen. So what will happen that suppose initially our R square value was 0.6, and on adding an important feature our R square value goes up to 0.8. So my new updated value is 0.8. Okay, then what will happen? Suppose my penalty value in this case was 2, so 0.8 into 2, it will be 1 minus 0.8, it will be coming out to be 0.2. 0.2 into 0.2, that will be 0.4. 1 minus 0.4, that will be 0.6, will be the adjusted R square. Okay. And if I add a useless feature in this, so what will happen? If I add a useless feature, the R square value still remains the same, there is no change, it is almost the same. So initially it was also 0.6, it was 0.6. So 0.4, 1 minus 0 R square, it is 0.4, and our penalty value was 2. Okay, so what will happen now? The value will be 0.8. So 0.8, it means 1 minus 0.8, that is 0.2. So we can see that on adding a useful feature, our adjusted R square value is increasing, and on adding a useless feature, our adjusted r square value is decreasing. Okay, so I hope you must have understood the difference between the r square and the adjusted r square. uh, and I want to tell you that the adjusted r square is more important in case of the multiple linear classic regression multiple linear regression.